Welcome everybody to lesson number 32 on coding. So coding is a big topic in today's society. Computer engineering, any type of codes, apps, making apps. And it's a developing skill that I feel is missing a little bit from the world today. So we're going to have just a very small taste of coding in this lesson. In your future, if you'd like to look into coding further, feel free by all means. And I'm actually going to put a couple of free coding applications on Google Classroom that if you want to play around with, you could. Now, today, coding, it's not so much solving things. I mean, it's using math and it's solving things mathematically, but it's more so understanding what a code would look like and interpreting the numbers to then fit what a computer would read and what a computer would spit out. When we start talking about the topic of coding, we are not learning coding exactly. We're learning to think step by step like a computer. We are going to learn how to read codes like a story. We will think about what the computer is doing step by step and what we can change to get different answers. So if you put in something into a computer, it'll give you one thing. How can we change what we put in to get something else? When we see the word code, we're going to think math. When we see the word steps, we might think, okay, equations. When we see the word print, you want to think what is going to show, what is the answer? We're going to be writing words, drawing arrows, and drawing boxes with codes. With reading code, we can predict outputs. By changing parameters, this means we will be adjusting numbers, and this we can think, what can we change to change the output? And then changing the rules means we will be adjusting equations, and modifying logic means we're changing outcomes. So all of that is just describing different vocabulary you might come across in coding, in the world of code. So what does print mean? Print means show the answer on screen. Print means outcome. So there's a little computer symbol. Think print X. So print X there. Show me X. What is X? Is what you would be telling the computer to do. Because we are not going to be coding on a computer right now, we're going to be using paper. We're going to write here. On paper, you're going to write output. Output colon is. That's how we're going to be writing it on our papers today. So for step one here, we're just going to be talking about variables. If you think way back to when we talked about variables, X and Y, what are they? In code, when we think about variables, we're going to picture these little boxes. So this box is our visual here. And we're going to picture in this box, X is going to be in the box. And if X is 5, 5 is in the box. So what will the computer show? If X is 5, the way we write it will be output X colon 5. If we want to show X equals 5 in a code, that's how we're going to write it for a code. That's just showing how to write it. Now with doing math with it, box, there's a little box there, arrow, X equals 3 plus this box, which is Y equals X plus 4. So therefore, we have X equals 3 and Y equals X plus 4. How are we going to write that in a code? So Y is going to be 3 plus 4. This box plus this box. So Y is X plus 4. So we want to know 7. So output Y is 7. That is how you would write it. So we solved this with our math. We solved this y with our math because we were given x. We know x is 3, x plus 4. So 3 plus 4 is 7. We know that because we did the math. How do we write that in code? Output y colon 7. That's our code. Now we're going to try one. It's asking you for output y. So we have to find our equation for y. It's giving us our x. So let's do our math first. Y, x is 1. 6 take away 1 is 5. So therefore, we know y is 5. So how do we write this in a code? So we're going to write output y colon 5. That's how we will write it. This is our code. Now, when we talk about decisions and logic, it's when we ask a computer something. We're asking a computer to make a decision. Use your logic. Use your thinking that's what we're telling the computer. So the computer's going to ask a question. Is x greater than 5? So we need to assign words. So let's say if x is greater than 5, if the answer is yes, we're going to say big. If x is not bigger than 5, if the answer is no, then we're going to say small. So we're going to pretend we inputted all this in a computer and those are our answers. We have big and small. Those are the words we chose. So what will this print? If x is 2, x is 2. So what is the computer going to print based on what we already set up? If x is bigger than 5, it's going to print big. Anything else, so if x is not bigger than 5, it's going to print small. So what's our output? Is it going to say big or small? We're going to use logic. We're going to use our words to see what it's going to say. So x is 2. Is x bigger or smaller than 5? X being 2, 2 is smaller than 5. So x is smaller than 5. So that means the answer is no. That means the word small is going to be printed. So our output, is it big or small? Our output is small. Now we're going to fill in the blank. X is 3 if x is... Now this is wanting us to make a choice. It's going to print small. That's what it's telling us. The output is small. What does that need to show? What symbol should be there for x if x is 3? So if x is smaller than 5, print small. So we needed to fill in our blank there. And now debugging. So whenever you are talking about coding, and I'm sure you've just heard this in your daily life on tech, on computers, on phones, if you need to fix a bug, debug this. There's a bug. My computer got a bug. My phone has a bug. That means there's a mistake in the code somewhere that needs to get fixed. So it needs to get debugged. So a bug, little picture of a ladybug there, is a mistake. Mistake. So if we see something, we see an error in a code, we can fix it. We can debug it. So this is what it's showing us right now. This is what it's giving us. What is the output y? What is wrong? And fix it. So here, our y is this. Okay, that's what it's showing us. Y is 2x plus 3. We know x is 4, so we can solve this. So we have therefore y is 11. So we can do output y is 11. What is wrong with this code though? There is something wrong here. Now, the answer is the way it is set up. This setup here is written incorrectly for a computer. In code, you can't set up multiplication that way. It needs to have very specific steps. So we need to add a special symbol to show the computer multiplication. So we can write here, the multiplication sign is missing. We know as humans, 2x means multiplication, but for a computer, we need to be very specific. So to fix it, 2, and then we have a little special symbol. The star means multiply. X. This now will tell the computer every step. The next example, x is 6. If x is greater than 5, output yes. So what is missing? So this is true. 6 is bigger than 5. So output would be yes. But there's no clear command. There needs to be a proper setup. So I'm just thinking of what to write here. We're going to write there is no clear command. There needs to be an if statement. Need an if statement. Now, okay, so we have our x is 6. Okay, if x is greater than 5, I'm going to write output yes. And I'm going to take away the quotation marks. Okay. And now, oh, sorry. If x is greater than 5, on the next line underneath, we write output. They put it all on one line. This output yes should be on the next line. It's a separate command. These are all separate lines. Okay, so again, that was our super quick little introduction to code. And you can complete your student handout matching this lesson. But like I said, I will post a couple things on Google Classroom that if you did feel like you want to play around with code, testing variables, testing outputs, maybe you want to try out something and think, hey, if I put in this, what will happen? What will print? What will be my output? Then you can try it out there. Okay, to finish off, what is decomposition? Decomposition is breaking down a problem into smaller steps. So it's just what it sounds like, decomposing, breaking it down. Think there's a big problem, you want smaller steps, and then you can solve it. So there's a problem here. A student studies 4 days. Each day, they study 2 hours. What are the total hours? Let's break it down in smaller steps. So for code, underneath you want all separate lines and you're going to break it down. So how many days? We have 4 days. How many hours? 2 hours per day. And the total number of hours. So we're going to go 4 times 2 is 8. So our total is 8 hours. Output equals 8. So we're going to write, therefore, the student studied 8 hours in 4 days. And just some reflections to think about. So, what did you learn today? What does decomposition mean? And what does it mean to predict code? So, what did we learn today? We learned how to break down problems. We learned what variables look like in code. We learned that when you speak to a computer, you have to be very concise and very precise with your wording and symbols. We learned how to solve problems, and we learned how to write a simple code using paper and words. What does decomposition mean? Decomposition means breaking down a bigger problem into smaller steps. And what does it mean to predict code? So it means figuring out a piece of the code and then predicting what the output would be. So predicting code would be finding some information and predicting what the computer will say. So if I am asking you to predict the code, for example, the big and small, predict the code if X is 2. Is it going to say big or small? You can use your mind to say whether you think it'll be big or small. That's predicting it. And then running it through a computer to see what the word would actually be would be actually doing it. Okay, very short, but just finishing off the last lesson. Thank you, and I'll see you next lesson.